In this module, we will introduce you to the core DevOps concepts like continuous integration and continuous delivery with Jenkins. You will also get familiar with Jenkins features, its advantages, and explore the Jenkins architecture. Before we dive into a discussion about Jenkins, let's first understand some key terms. The practice of automatically building your code periodically is called continuous integration. The resulting binaries after building the code can also be deployed automatically to the target environment. This practice is called continuous delivery or continuous deployment. To paraphrase, Wikipedia defines continuous integration, CI, as the practice in software engineering of merging all developer working copies to a shared mainline several times a day. And continuous delivery as a software engineering approach in which teams produce software in short cycles, ensuring that software can be reliably released at any time. It aims at building, testing, and releasing software faster and more frequently. Now let's see how it works in practice. During the course of a regular software development lifecycle, one or more team members check in their code regularly into a source version control system or repository like Git, Subversion, etc. The CI server then fetches these fresh changes and integrates them. It then runs the build processes and produces a bundle of software build artifacts. These artifacts are then versioned and stored in a build repository. The CI server then runs several automated tests like unit tests, integration tests, etc. to validate the build artifacts. CI service may also send notifications to the team about the success or failure of this CI run. The CI server can run this entire process many times a day based on several triggers. For instance, upon every check-in of new source code from any developer, or on a periodic basis. Why are these DevOps practices becoming so popular these days? And what benefits do they provide? One of the key driving forces behind CI and CD is to detect problems or bugs as early as possible in the development lifecycle. If we only build and integrate our code right before a QA cycle or before a big release, we are running a high risk of last-minute failures in our integrated code base. By integrating all the changes coming in from various team members and building the integrated source on a frequent basis, these risks are minimized. Effective application of CI and CD practices can provide a greater confidence to the team in building their software products. As new changes and features are introduced into the source stream, the team can confidently accommodate these changes. Since the entire code base is integrated, built, tested, and deployed with sufficient frequency, the potential bugs and errors are caught earlier on in the cycle. The faster feedback loop inevitably results in better quality software. Since the builds are automated and the source is integrated and continuously built and deployed, there is little to no delay in producing a set of artifacts and making them available to the customers. All builds are stamped with a systematic build number. This results in a fully tractable build and deployment process. It gives us the ability to take any particular version of the software and trace back the exact commits which were made to produce that build or version of the system. This is incredibly helpful while trying to troubleshoot issues for support purposes. Over time, your CI and CD processes collect valuable information about your source code. This information, or metrics, can be tracked and analyzed to give us a broader perspective of your code and team. You can answer questions like, is your code coverage increasing over time? Are your builds taking longer and longer to complete? Do you have more or less build failures per day? This is tremendously useful for the development team and organization as a whole. If there is a noticeable degradation in quality, corrective measures may be taken earlier on in the development cycle. Since most of the build, integration, and deployment processes are automated with the help of CI and CD, teams can ship the products faster and more consistently. Some organizations have taken automation to the extreme and they ship their code several times a day. All these benefits result in a lower cost of development and ultimately have a huge impact on the overall bottom line of the company. There are various products, frameworks, and tools available which can help us implement CI and CD pipelines in our environments. Here are only a few of the most popular ones. Some are open source and absolutely free, with huge community support behind them, whereas others are commercial proprietary products produced by some very reputable companies. Some options let you host a CI server in your network infrastructure, and other products are completely hosted in the cloud. We can evaluate any of these options based on the business and technical requirements of our project, and of course their suitability to our environment. In this course, we will obviously focus our attention to Jenkins. During the software development process, the software team needs to perform several tasks, such as committing the code frequently, testing, staging builds, and getting the code from the development into the production environment. Performing all these tasks manually within the development process consumes a lot of time and focus. In addition, running regression test cases is a very time-consuming job if it is manual testing. Apart from the fact that manual processes are more tedious and inefficient, manual integration also increases the likelihood of mistakes, rate of bugs, configuration issues, and customer frustration. So how can you ensure a high-quality product with minimal delays and mistakes? Let's explore! The DevOps processes enable you to overcome the limitations of the manual approach. As soon as new code is checked into the source code repository, it can be automatically built and tests can be run to validate the new code. This process not only validates the new code itself, but also ensures that it works in an integrated manner with the rest of the code base. Once the code is validated, we can go ahead and deploy the new build onto the dev, QA, and production deployments. In some companies, this process is repeated thousands of times a day, and customers get new software versions within moments of the new code getting pushed to the source code repository. Introducing continuous integration, continuous delivery, continuous deployment, and other DevOps practices in an organization radically changes the whole development process. It enables and triggers a series of incremental process improvements, going from a simple scheduled automated build right through to continuous delivery into production. Processes that were used before the implementation of DevOps practices had many flaws. As a result, not only the software delivery was slow, but the quality of software was also not up to the mark. Developers also had a tough time in locating and fixing bugs. Therefore, implementing a DevOps culture and infrastructure can help you in streamlining the development process right through deployment, detecting and fixing bugs faster, providing a useful project dashboard for both developers and non-developers, and ultimately in helping the teams deliver more real business value to the end user. Jenkins is one of the most popular tools for implementing continuous integration, continuous delivery, and continuous deployment pipelines for any platform or technology. It is an open source automation tool written in Java with plugins built for DevOps purposes. Jenkins can trigger a build for every change made in the source code repository, for example, a Git repository. Once the code is built, Jenkins deploys it on a test server for testing. The concerned teams are constantly notified about the build and test results. Finally, Jenkins deploys the build application on the production server. Thus, Jenkins helps in cutting down costs by enabling teams to automate their build and release process. To enhance its power and usability, Jenkins supports thousands of plugins. There is a huge and active community behind Jenkins, and they are constantly contributing to and updating the plugin ecosystem, which makes the Jenkins platform even more powerful and flexible every day. In an improbable scenario where you cannot find a suitable plugin for your project or situation, you yourself can extend Jenkins by developing additional plugins. That is the advantage of using an open source platform, which has a strong and generous community behind it. So we saw Jenkins has tremendous advantages, like it is a very low-cost open source solution, it has an active community behind it, and it has a vast ecosystem of plugins. Apart from that, the key tangible benefits of Jenkins are that it increases the developer productivity and brings greater agility to the development process by automating the mundane but important tasks. To summarize, Jenkins is an open source platform that can handle any kind of build, continuous integration, continuous delivery, or DevOps task. You can integrate Jenkins with a number of testing and deployment technologies. Jenkins is a powerful platform that allows continuous integration and continuous delivery of projects, regardless of the platform you are working on. Jenkins can be extended by additional plugins. It is a tried and tested platform which is widely used in the industry, from small startups to very large corporations. Let's get technical now and answer some key questions about Jenkins. How does Jenkins work? What are the key terms and concepts related to Jenkins architecture? Well, there is no surprise that Jenkins implements different DevOps steps with the help of plugins. Plugins allow the integration of various DevOps stages within the Jenkins framework. If you want to integrate a particular tool, stack, framework, or platform, you need to install the Jenkins plugins for that particular tool or framework so that Jenkins can work with it seamlessly. For instance, you may want to use Git via Git plugin, Maven 2 via Maven plugin, and some cloud-related frameworks using AWS or Azure-specific plugins. Now, let us explore the architecture of Jenkins and see what are its core components. Generally speaking, Jenkins uses the master-slave architecture to manage distributed builds. In this architecture, master and slave communicate through TCP/IP protocol. The main Jenkins server in this distributed architecture is the master server. The master's job is to pull the SCM repositories, which could be anything from Git to Subversion to CVS, etc. Schedule build jobs. Dispatch builds to the slaves for the actual execution. Monitor the slaves, possibly taking them online and offline as required. Record and present the build results. So primarily, the master's job is to orchestrate the builds and jobs across the whole cluster. That being said, a master's instance of Jenkins can also execute build jobs directly, whereas a slave Jenkins instance is a Java executable that runs on a remote machine. The slave Jenkins instances accept requests from the Jenkins master instance and execute the job and report back to the status of the master. Slaves can run on a variety of operating systems. You can configure a project to always run on a particular slave machine or on a certain type of slave machine, or simply let Jenkins pick the next available slave. For example, in this diagram, you can see that Jenkins architecture consists of a Jenkins master, which is managing 2 Jenkins slaves. The Jenkins master distributes the workload to the slaves, which accepts the requests given by the master. Additional slave nodes can be added to this architecture as the load on the system grows. Let's end this module with a quick recap. You now understand that DevOps practices like continuous integration, continuous delivery, and continuous deployment help in increasing the productivity and streamlining the software development process. DevOps practices reduce the overall risk of the project by discovering errors early in the cycle and thus increases the overall quality of the product. Jenkins is an excellent open source automation tool written in Java with plugin support. It is a tried and tested platform for implementing our DevOps pipelines and components. In the next module, we will walk through the process of installing and configuring Jenkins.